Alright, we are in section 5.2 talking about circles and the equations of circles, and now we're going to talk about completing the square because that's what we're going to use to change an equation of a circle from a general form where it's all been multiplied out to a standard form where we have it in the form we just talked about with binomials squared that tell us the center and then the other side, the radius of our circle. Now, the reason these specific instructions are going to work well, specifically because of item 2, is that if an equation is a circle, then the coefficients will be the same. They will be equal in a circle, but they won't be for the other conic sections that we talk about. So they will be the same for both x squared and y squared, if it is in fact a circle. Okay, so now with that out of the way, let's just talk in general about how to complete the square. So step 1, position all terms containing variables on one side of the equation, grouping terms with like variables together in descending order of exponents. Position the constant on the other side of the equal sign. So, for example, we might have like ax squared plus bx, and then ay squared plus some other variable, let's call it dy, equals our constant c on the other side. Something to that effect. Now, when you're actually writing that out to complete the square, I like to actually split up and leave some spaces. So leave a space here and here, because when we complete the square, we're adding in numbers that will turn those into perfect square trinomials. So step 2, divide both sides by the coefficient of the quadratic terms. So if there's a number in front of x squared and y squared, and for a circle it should be the same number, go ahead and divide that out from everything first, and then it just gets it out of the way. So then we'll have something like x squared plus b over a x plus, we're going to leave a space to complete the square, and then we divide out the a from everything, so we'll have y squared plus d over a y plus, we're leaving a space to complete the square, and then of course we also divided that side by a. Okay, so now to complete the square, what we do is we take our b over a and we divide it by 2, we half it. So we're going to half our b over a by, multiplying it by a half, if you want to think of it that way. So you're going to have b over 2a, and then you square it, and then you add it. So that space right there, I'm going to add in my b over 2a squared. And then this space right here will be d over 2a squared added to this side. And then what we add to one side of the equation, we have to add to the other side. So we're also going to add a b over 2a squared here and a d over 2a squared to our constant c over a for the other side of the equation. Okay, and then our very last step will be to factor. So we'll have an x minus b over a, it's actually 2a, it's that number you get when you half it before you square it. And then it'll be y minus d over 2a. And then this side will be a compilation of all of this stuff added together. That will tell us what our r squared is, or whatever, right? So for this case, for circles, that would be our r squared. So all of this is going to add together to create r squared. Okay, for the first couple of problems, we're just practicing completing the square, and so we don't have x's and y's, we just have one or the other, but then we get down to some problems that actually are circles. All right, let's follow our instructions. So we're going to move our constant to the other side and leave some space. Now we're going to half the 4, so 4 divided by 2, and square it. So that's going to be 2 squared, which is 4. So we're going to add 4 here, and add 4 here. And then we just factor. So factored would be x plus 2 squared equals 10. Again, this isn't a circle because we don't have the y in there. Okay, let's try this one. This one has an extra number in front. Let's go ahead and move everything over that we need to move over, which is basically just the constant, right? Then we're going to divide everything by 2. So that gives us y squared minus 7y equals negative 5.5 if you want to. It's not really right. Okay, so now we're going to do half of negative 7, and so half of that is 2, but then we have to square it. So that would be 49/4. So we're going to add that to both sides. Okay, so that gives us this part, which is going to factor into y minus 7 over 2 squared. Notice how because you're always squaring the number, if it's negative, it's going to turn it to a positive, or if it's positive, it stays positive. And then the other side of this would be 22/4, so 49/4 minus 22/4 will be, if I believe I'm doing my math right, 2, so 27/4. All right, so there, we've completed the square. We're not actually finding center and radius because it's not actually a circle. Okay, next one is a circle. So if you want to, at the end we can find the center and the radius. Okay, so we've got our x terms grouped together. Add something in there. And then we have our y terms grouped together. Add something there. Add our 15 to the other side. Half of 6 is 3, so 3 squared is going here, and what we add to one side we have to add to the other side, and then half of negative 10 is negative 5, so we're doing negative 5 squared here, which is the same thing as just 5 squared, right? That saves me in writing to not worry about that negative. Okay, so I get x plus 3 squared plus y minus 5 squared equals 15 plus 9 plus 25, which is 24 plus 25, which is 49. Okay, and that gives us everything we need to know that our center of this circle would be at negative 3, 5, and the radius would be 7. Okay, let's look at this last problem here. We've got x squared minus 3x plus some number. And then we have y squared, but there's no second term with just our y value, so we're not going to need to complete the square on that. There's also no constant other than 0, so we're good to go on that one. So half of negative 3 is negative 3/2. I'm going to square that and add it to both sides. And then factor. So we get x minus 3/2 squared plus y squared equals 9/4. And then if you really want to apply this to circles, our center would be, because it is a circle, would be at 3/2, 0, because there's no number adding or subtracting here. And then our radius would be the square root of 9/4, which would be 3/2.